So here's an example molecule, carbon tetrafluoride. The first question, are we going to have ionic bonding or covalent bonding? And carbon and fluorine are both nonmetals. So that means they're going to be sharing their electrons. We have covalent bonding. So we're going to follow the 7-step process. Step number 1, figure out the skeleton arrangement. The most symmetrical way to arrange these atoms would have the carbon in the center and the fluorines on the outside. Then we want to count valence electrons. The carbon is found in group 14, so it has 4 valence electrons. Fluorine is found in group 17, so each fluorine has 7 valence electrons, but we have 4 of them, so that's 28. So the total is 32 electrons. When we draw our Lewis picture, we have to have all 32 electrons accounted for. Then we connect the terminal atoms to the central atoms by putting a single bond, which requires 2 electrons. So we need to connect each one of the 4 terminal fluorines to the central carbon with 2 electrons. That uses up our first 8 out of our 32 electrons. Then we satisfy the terminal fluorine next, and each fluorine wants the octet rule satisfied, and fluorine is trying to get to group 18, so it needs 8 electrons around it. Right now each fluorine has 2, so we put 6 more, 3 pairs of 2, top, bottom, and right for this fluorine, plus the 2 bonding will make 8 electrons around that fluorine. And we do the same thing for the other 3 fluorines. Next, we would satisfy the central atom, and the carbon atom already has 8 electrons around it, so that group 18 is satisfied. We don't need to rearrange electron pairs, step 6, and we don't have any extra electrons, step 7. So the final thing we need to do is write this with our bonding electrons drawn as a single line. So instead of showing 2 dots for the electrons that connect the fluorine to the carbon, we draw that with a single line. We still show the other 6 electrons on each terminal fluorine as 6 dots. So looking at this picture, or looking at the first picture, if we circled all the electrons, the fluorine believes it has 8 electrons around it. So does this fluorine. So does this one. So does this one. And the carbon also sees it has 8 electrons around it. So notice we're counting the electrons twice. The fluorine thinks it owns those 2 electrons, and the carbon thinks it owns those 2 electrons. That's the essential part of covalent bonding. The electrons are shared between the 2. So this picture shows you the 2 different types of electrons. The electrons that are involved in the bond are called bonding electrons, and the electrons that aren't in the bond are called non-bonding electrons. And non-bonding electrons can also be called lone pair electrons. So this would be the correct Lewis structure, showing all the bonding and all the non-bonding electrons in carbon tetrafluoride. The most bonds you'll ever have between 2 atoms is 3. A single bond is 1 line, A double bond would be shown as 2, and a triple bond would be 3. One line, remember, represents 2 electrons, so a double bond is made up of 4 electrons, and a triple bond is made up of 6 electrons.